Good evening, everyone. Welcome to this webinar that we are conducting to celebrate International Observe the Moon Night. I'm going to be your host for tonight. My name is Tarun Sharma. I'm an astronomer associated with Space India. Now, Space is an organization that deals in the field of astronomy education, popularization, and making people aware about the importance of astronomy. We have been in the industry for more than 20 years now, and annually we reach out to more than 20,000 students, making them capable to unlock the secrets of the universe. We deal in astronomy education, astro-tourism, as well as making tools and instruments related to astronomy. So tonight we are here to celebrate International Observe the Moon Night. Now it is very important. The reason being, Moon is our closest celestial neighbor. That means if you want to understand about the universe, about the space, you have to go out of the earth, you have to go into space and study the objects that are out there. Now, when you talk about the moon, it is the closest object to us. So, when you think about exploring something that is out of earth, so moon comes for the first time in our mind. So tonight, the plan for the observation is that first I'll introduce you to the moon. I'll tell you some details in brief about the moon. Okay, its features, why is it so important to study, and why astronomers are very eager to know more about it. Later on, we have got a telescope with us and a camera. So we'll be pointing that telescope towards the moon and we will be showing you the moon in great detail. We will be exploring the features of the moon. Okay. After that, we will be exploring the brightest planets that we have in our night sky. Okay, we have Jupiter, we have Saturn. So we will be showing you Jupiter and Saturn in great detail. We'll be having the moons of Jupiter in the field of view tonight, so you'll get to see them as well as the moons of Saturn. You all know that the Saturn is known as the Lord of the Rings, so we'll also get to see the rings of Saturn. All right, now some of you have already submitted questions to me and I have got more than 300 questions with me. Okay, so unfortunately I'll not be able to cover all of them, but I have asked my team to shortlist the most common and most important questions out of them. Okay, so towards the end of the webinar and during the webinar we will be discussing those questions and we'll be answering those questions. All right, so let us now go and let us learn about the. So that was a super close up of the lunar craters and the mountains which are out there, right? And I'm sure that you all were amazed by the look that we have, right? Wasn't that amazing? So, provided we get clear skies tonight, I will show you a view which will be very similar to that. Now, obviously, it will not be exactly like that because these are the visuals which are captured by a spacecraft which is orbiting the moon. All right. So, let's get started. Let's get to learn about the moon, which is also known as the Luna, Chanda Mama, and there are many names of this celestial neighbor that we have. Now, moon is a generic term that we use for any object which revolve around a planet. Okay, so basically a satellite, right? And every natural satellite of a planet is known as a moon. It's moon, right? But then the question comes, what about our moon? What about the Earth's only natural satellite? What is it called? So it's a common misconception that people say that moon is not the real name of our Earth's satellite. It is actually Luna. Okay, so let me first break that myth over here, and it's break one of the most common misconception that we have, that Luna is just another name of our moon. Our moon is called as the moon. Okay, it does not have any specific name because when the moon was observed for the first time, when it was shown, and for centuries, and in fact until Galileo's time, we were not aware that any other planet also has a moon. So what we used to think, that our moon is the only moon in the solar system. So that's how it is. So our moon is called as the moon, and it is also named as Luna, and in Hindi we call it Chand. The children call it Chanda Mama, and it has been part of our life since ages. Okay, when we were living in caves, when we were living in jungles, it has been part of our life, and even today, no matter when you talk about a small child, maybe 2 or 3 years old, he gets excited whenever he goes out and see the moon, right? When you talk about the grown-ups, you know that if you just look at the movie industry, there are so many songs and so many scenes which are dedicated to the moon, right? Which are kept in the situation, keeping in mind the moon, right? The moon becomes the centerpiece in that. Okay, similarly, there are, when you grow old, it becomes like your companion. Okay, and when you just go outside and look at this bright celestial object out there, you feel just amazing, isn't that? So that is why it is very, very important. Okay, and also, when you look at it, right, it has samples which are dating back to the Earth's and Moon's origin. Okay, so when we study it, we also get to study about the solar system or the condition at that time. All right, so I told you that the Moon is the only natural satellite that Earth has. Okay, it's the closest celestial neighbor we have, and if you talk about its rotation and revolution period, it is 27.3 days. Now, you will read two numbers. Somewhere you will read 27.3 days, and somewhere you will read it's 29 and a half days. And actually, both are correct. When you talk about the sidereal revolution period or the sidereal rotation period, it is 27.3 days. And when I say sidereal, it actually means the revolution and rotation with respect to the stars. And when you say synodic, synodic means with respect to our sun. Okay. Now it also shows us different phases in our night sky, and actually, if you talk about naked eye visibility, it is the only object that can show you phases. Okay. Now the clouds have moved a little bit, so let me just get you the visual of our moon for the very first time tonight. So I hope that all of you can see the moon in the video. Just give me a yes, give me a thumbs up in the comment section so that I can see it. All right, so the clouds have moved out of above the moon, and the moon is visible in all its glory. Let's just everybody just have a look over here. Just see how amazing it looks. And again, the clouds have covered the moon for us. But anyways, we got to see a little bit of it. Okay, so we have a lot of time left, and we will get to see it again. Alright, till then, let's come back to our presentation. Let's get to learn more about the moon. So I was telling you about the sidereal and the synodic period. So sidereal is with respect to the stars, and synodic is with respect to the sun. Alright, now moon does not have an atmosphere. Okay, it has a very thin layer of exosphere. And thanks to the Chandrayaan mission by ISRO, we have found water in solid form over there. Okay, let's move forward now and let's understand that how the moon was formed. So it was not the case like this forever since the beginning of time. Okay, and there are various theories that we know that how the moon formed. Okay, but out of them, the theory that I am going to explain to you now is the most accepted theory. It is known as the giant impact hypothesis. Okay, so it is believed that this is how the moon was around 4.5 billion years ago. Very young, very hot, right? Slowly and slowly it cooled down, but still inside it was filled with lava. And now you know that it does not have an atmosphere, right? So whenever a rock would hit it, it would puncture the moon, the lava would splash out, right? And it would be on the surface. So this is how the moon was like. And if I give you an analogy, if I give you a comparison, the moon was like a choco lava cake. I'm sure you all have had it, right? The famous Domino's choco lava cake, right? So it has liquid chocolate inside, and then you have the outer covering. But let's say you puncture it, you poke your finger into it, the liquid chocolate oozes out. Then you go and keep it in the freezer for some time. After that, when you take it out, let's say 1 or 2 hours later, you would notice that the chocolate has frozen. The same thing happened with our moon as well. In earlier times, when the rocks would use to hit it, the lava would flow outside, but with time, it got frozen and it turned into these dark black features on the surface of the moon. And then started the second phase when it was solid, when moon became completely solid. So now when rocks would hit it, it would not be able to puncture it because there's no lava to flow outside. So what will happen? Huge craters will be formed, huge depressions will be formed on the surface of the moon, and that is how the moon would turn out to what it looks like today. So this is how the moon was formed, and this is how the moon evolved to become what it looks like today. So I've got the signal again that the clouds are disappearing. So let me just get back to the view of the moon. So here we are again. So now you can relate that how those black features came into the being and how those bright spots came into the being. So you all can now understand it better, right? So that black features that you see over here, all these black features are actually nothing but frozen lava. Okay, and all the bright spots that you see, they're actually huge depressions which were created because of the meteoroid strikes. Alright, so let's get back to the presentation that we were doing. So this is how the moon looks like today. Now let's move further. Now I told you that it's been part of our stories since ages. Okay, because when you look at the moon, it's been there, right, since the beginning. And when earlier time, when you talk about people living in caves, jungles, right, so astronomy was their companion. if you talk about today, and if I ask you this question, that how many of you actually go out and observe the night sky daily? How many of you go out daily and have a look at the moon, or have a look at the stars, or keep a track of which phase of the moon is there in the night sky today? Okay, and which all stars or which all constellations would be out there? And let's just do a poll right over here, and let's see how many of you do it daily. If you do it daily, or let's say once in a week, just write it down in the comment section. Okay, and let's take a poll right over here, that how many of you actually do it. And let's be honest with yourself. Okay, because what I'm trying to say is that I'm just trying to show you the picture that we have today. Because as a what do you say, as humans we have been disconnected from the nature. Okay, as we are developing, as we are going towards the modern era more and more, we are getting disconnected from the nature and astronomy, right? So I can see that a lot of you do it. If you do it, that is really really amazing thing that you are doing it. Okay, that means we still have hope for astronomy, right? So we are getting disconnected from nature and from astronomy. Whereas if we talk about our ancestors, they were in sync with the nature and astronomy. In fact, their life was controlled, okay, and their life was organized because of astronomy. Let's talk about the night time. So you have had your dinner. What do? You play on your mobile phone, you play on your PlayStation, you watch TV or work on the laptop or computer, right? Or read a book. But none of, well, like most of us do not go out and observe the night sky. Whereas if I talk about earlier times, every night they used to just lie down under the open sky and observe the night sky. They used to observe the stars which are out there, and make patterns by joining those stars. Okay, and that is how the constellations came into the being. And the same thing is with the moon also. Like when you look at these black spots, when you look at these bright spots, generation of today might not be so creative and make shape out of it, right? But when you talk about our ancestors, they used to make stories out of it. They used to imagine characters on the moon. So these are some of the famous shapes and images that people used to imagine on the moon, right? You can see a man, you can see a scary face, and you can see a rabbit on the moon, right? So that happened because of our imagination, because of our curiosity, and because we used to look at the moon. Okay, I'm going to interrupt once again because we have got one of the best visual for tonight of the moon. So let's get back to the moon. Just have a look over here. Let me just get out of the view so that you can enjoy it completely. Okay, so let's just take a poll over here. Let me know how many of you are enjoying this view of the moon. If you are enjoying, just write down in the comment section so that I'll get to know. So I can see your feedback. You all are enjoying this view. Okay, now I'm just gonna go one step further and I'm gonna show you one of the craters on the moon. Okay, because I don't know for how long the clouds will give us this liberty to enjoy this view, right? So I'm just gonna give you a close-up view on the moon. Okay, so I'm just gonna show you one of the craters that we have right over here. So do you see that? So that is one the craters. These are the craters on the surface of the moon, right? And you can see the image shaking a little bit. That is happening because of the atmosphere of the earth, like because of the turbulence, because it's cloudy and then it's windy as well. So because of these two reasons, you can see there is the image is actually shaking a little bit. Now, this is how a detailed photograph, a very sharp photograph of the moon looks like, right? And you can see a lot of things on it. You can see the bright spots out there. You can see the lines coming out of it. You can see black features on it, right? So, if you talk about features that we have on our moon, these are some of them, okay? And these are actually the main features on the moon. So first thing, the back features, the black spots that you see on the moon, they are known as mare, okay? And I already told you that is frozen lava. The second thing, all the bright spots that you see over here in this photograph and in the real moon, they are called as craters, okay? Then you can see the rays coming out of the craters, right? So we call them simply rays. Then comes terrae, okay? And the last one is regolith, okay? One by one, we will talk about each of these top features. Number one is Mare or Maria. So I told you that when the moon was young, it was filled with lava and it was solid from outside. So whenever a rock would hit it, it would puncture the moon. Hot lava would flow outside. With time, that hot lava got frozen and it turned out into what we call as the mare. Okay, now it's very strange because mare is a Latin word which means sea of water, but we all know that there is no liquid water on the moon. So why did we call it mare? Why did our ancestors named it as mare? Okay, so the reason is because they thought that it is liquid water on the moon. Our ancestors used to think that the black spot that you see, they are actually sea of water out there, and that's why they called it the mare. All right. Now, if you look over here, you will see a lot of circles in this photograph, right? So all these circles that you see, all these depressions that you see, these are actually nothing but huge depressions that we call as craters. Depression means gadde, bade bade gadde. Okay, so on the surface of the moon, we have these huge depression which are very very deep. Okay, and again the reason is same. They were formed because of the meteoroid, or sorry, the space rocks used to hit the moon and used to create those huge depressions. Okay, and in the center of this photograph, or in the center of this huge crater, you can see some structure. Okay, some people say that it's a man, but it is actually a hill, a mountain in the center of the crater. The crater that you see, it is almost 100 kilometers in diameter. So it's that big. Just to give you an idea, you can fit in 2.5 Delhi inside this crater. It's that big. Okay, and the mountain that you have in the center, it's 100 of feet taller. It's not a small boulder that you have in the center, it's hundreds of feet taller. So every crater will have these mountains in the center. Okay, and also it will have boundaries around the rim of the crater. Okay, now as the moon made, as the space rocks made these impacts on the moon, okay, used to hit it, used to create mare and crater around those regions, okay, around the regions of crater and mare, the surface got lifted up, okay, and it created lot of highlands on the surface of the moon. Those highlands are what we call as the terrae. Okay, so terrae are basically the highlands on the surface of the moon, right? And how they are created, again, because of the repetitive impacts of the space rocks. And whenever the crater used to form, all the material would eject out around the crater and it will spill out, right? And as these material would reflect the light of the sun, what you see are the rays coming out of these craters. So what I showed you in this photograph, the rays that you see, that is actually the material ejected out of the crater which is reflecting the light of the sun, right? Now we come to the last feature of the moon, which we call as the regolith. Now regolith is basically the topmost layer of the moon. In simple terms, it's the soil of the moon. Okay, and it is very, very fine. In fact, finer than your talcum powder. Again, why? Why is it so fine? The answer is very simple, because of the repetitive impact of the space rocks. The rocks on the moon surface, it got crushed, many a times, and that is how it became so fine. But don't think that if it is fine, it is very soft. In fact, it is very, very abrasive. Okay. Now, the most striking feature of the moon is that it shows us phases every day. The shape of the moon that you can see in the night sky, it changes every day. And also, the rise time and the set time of the moon changes every day. Why does that happen? The answer is very simple. Number one, it does not have its own light. Okay, so what happens? It only reflects the light of the sun. Okay, now at any given time, only 50% of the moon would be lit up. Like if you look over here, you have the earth in the center, and then we have shown the moon at different position in the inner circle. Okay, have a look at the inner circle. You have the earth, and then around it you have the moon at different stages, right? You have the sunlight coming from the right side. Okay, so at any given time, if you see, only half of the moon is lit, but how much of that is actually coming towards the earth, that will decide the phase of the moon. Now just imagine, you are the earth, I am the moon, and behind me is the sun. Okay, let's consider the situation of this that we call as the new moon. So the sun is behind me, right? So the light will fall on my back. After reflection, it will go towards the sun. Will it come towards you? Will it come towards the earth? No. So will you get to see me in the sky? No. Right? That is what we call as the new moon. And as the moon moves in its orbit, right, the geometry becomes such that the portion which is lit up by the sunlight, let's say you are over here on the second spot. Okay, let me just get pen over here. So you can see this one, right? This phase of the moon. All right, you can see that at this time, some part of that lit up area will be visible from Earth. Okay, and that is how we get to see the crescent shape of the moon. Okay, so this is known as the crescent moon. All right, as it moves further, the portion which is visible from the earth, it starts getting bigger and bigger in size. So although only 50% of it is lit up, but we can see around 50% of that, this much area from the earth. Okay, so that is why it becomes half circle. So this is known as half moon or the first quarter. Okay, as it moves further, we get to see more than half of the lit up area. So it becomes more than half in the sky, which we call as the gibbous moon. Now let's talk about this position, and you can see that the complete light. So this geometry that you see over here, how it becomes, let's say you are the earth, I am the moon, so the sun is behind you. So all the light that is falling on me will reflect towards you. So what do you see? You see a complete circle in the sky, right? That we call as the full moon. As it moves further in its orbit, what will happen? The shape will start decreasing. It will go back to gibbous, then to half, then to crescent, and then back to new, right? Now, here also it is half, and here also it is half. So how do you differentiate? So basically, if you look towards in this cycle, as it goes from the new moon to full moon, you can see that the moon is increasing in size. And as you go from full moon to new moon, you notice that the moon is decreasing in size. So the increasing phases are what we call as the waxing phases. So you can see the waxing crescent over here. You can see the first quarter or waxing half, and you can see the waxing gibbous. And then decreasing phases are known as waning phases. So waning gibbous, then waning half or third quarter, and then waning crescent. Right? So I hope that you are clear. Now I'll tell you a simple trick to identify whether it is a waxing phase or a waning phase. If you just look over here, so these are the views that you see from Earth. Alright, so if you see the first quarter, it is lit up on the right side. If you look at the waxing crescent, it is lit up on the right side. If you look at the waxing gibbous, it is lit up on the right side. So these are known as waxing phases. When you see that the moon is lit up on the right hand side, it is the waxing phase. And when it is opposite, that it is lit up on the left hand side, that's we call as the waning phases. Right? So I hope that now you are clear that whenever you will see the moon in the night sky, you just have to see which part is lit up, whether it is the right hand side or the left hand side. Okay? If it is right, it is waxing. If it is left, it is waning. And if you talk about the complete lunar cycle, so the lunar cycle is of 29 and a half days. Now what is the lunar cycle? It's basically the time duration from new moon to new moon, or one full moon to the next full moon. Okay, that means this complete cycle from new moon to new moon is what we call as the lunar cycle. Okay, so we are on the 9th day of the lunar cycle, actually the 10th day of the lunar cycle as we are talking about. We have completed 9 days and now we are in the 10th day of the lunar cycle. When you observe the moon, okay, no matter which day, which month or which year, you will only see this phase of the moon, right? You will only see this type of moon, this one that we have over here. So I got a little bit excited and I drew it wrong, but this is the phase or the moon that we get to see whenever we see it from the earth, right? If anybody is out there who has seen the moon like this, that is on the right hand side. So all of us have only been able to see the moon like this. So this is known as the near side of the moon, or the side that is facing the earth. So the moon is actually locked with the earth. Why? So that is because of the gravity play of the earth and the moon, and it is such that the moon completes its revolution and rotation in the same time. Remember I told you rotation and revolution period, the sidereal is 27.3 days and the synodic is 29.5 days. So by the time it completes one rotation, it has also completed one revolution. So what appears like from earth is that we are only seeing one side of the earth. So it is kind of locked with the earth. Now normally people believe that the moon is not rotating, but it actually is. It is rotating. Okay, so we never get to see the far side of the moon. Okay, if you want to see the far side, you'll actually need to become an astronaut, board a spacecraft and go on the other side of the moon. Then only you can see the far side or the other side of the moon. But does that mean we can only see 50% of the moon? No, because from earth only one side is facing towards the earth and the other side is facing always away from the earth. So do we get to see only 50%? Let's see what is your opinion on this. No, we actually see more than 50% of the moon. Okay, that has to do with the rotation and revolution and then the orbit of the moon as well as the tilt of the orbit of the moon. Okay, so we actually get to see 59% of the lunar surface if we are looking at it from the earth. If we are in an orbit around the moon, then we can see 100%. But if you are on Earth, throughout the year, you can only see 59% of the lunar surface. Okay, why? Let's have a look over here. So this happens because of something known as lunar liberation. So as the moon goes, moon is going around the earth in an elliptical orbit. Okay, so sometimes it is closer to us, sometimes it is farther from us. Okay, so that is why its size also gets bigger and smaller. When it goes away from us, it appears a little smaller, and when it is closest to us, it appears a little bigger, that we call as the supermoon. So you can see that the moon is actually kind of wobbling in the sky. Okay, it is going like this. So you see some extra portion on the north pole and the south pole, and you see extra portions on the eastern and the western side of the moon, right? So this happens because of something that we call as the lunar liberation, and because of this, we see more than 59% of the moon. And this is how the moon looks like tonight. I've already told you, I've already shown you the visual of the same, right? So this is the photograph of the moon that we see today. Okay, and you can see how beautiful it looks like, and as the sky gets clear, we'll get to see more of this. Okay, so that was about all about the moon that we had to discuss tonight. Now I'm sure that you might have lot more questions, you might have lot more queries. Okay, and I'm sure that you might have this thing in mind, that if you want to learn astronomy, okay, how do you do it? So that is where space comes into the picture. Now we have been in this industry, and we are the leader in the field of astronomy education in India. We are the largest non-government organization working in this field. Okay, and we have been training students and public on astronomy since 2000, right? For last 20 years. Okay, so in these times when most of us are logged, are stuck at home, some of us are have completed our school and waiting for to get an admission into a college. Some of us have completed the college and waiting for some job. Okay, some of us are working, but like and love astronomy and want to pursue it as a hobby. Some of you might want to pursue astronomy as a career, right? So, what are the options that you have? How can you learn? So, for people like you who wants to learn astronomy and become an astronomer, make astronomy your career. So, for you, we have online courses. Okay, now since obviously we cannot call you at a location and teach you astronomy, but that should not stop us from learning, right? Just like this, in this tonight, just like we have assembled online, we are meeting virtually, and I'm showing you all these visuals of the moon, and I'll show you the visuals of Jupiter and Saturn. So you don't need to travel anywhere, and from the comfort of your home, you can learn astronomy. So let's just have a look at it, that how you can do that. So what I told you about right now, what the video that you saw was actually about our online club, online astronomy club that we have named as I Astronomer. So all of you can become astronomer by enrolling to that club. You have the website address. You can just go and explore your options if you want to do that. Now, some of you are thinking that this is the ending of the webinar. Guys, this is not the ending. We have only started, right? Remember, I told you that we will be doing feature identification activity. Now, you might be thinking that I have ended the presentation. The weather is cloudy. So how do I actually do that, right? So it is not the end. We are going to be here till 9 o'clock. Okay, so you have around 45 minutes left, and you might be thinking that if the weather is cloudy, how exactly are we going to do that activity? And we'll actually do that. Okay, the answer is we are going to take help of a simulation software. Okay, now before I jump onto that, I want all of you to be ready with the document that we had sent you. Okay, the map of the moon and the photograph by the LRO. Okay, keep that handy because you will need that. And till the time you get it all arranged, I'll just get some questions that you asked us, that you had submitted in the registration form. Okay, so I will be answering some of those questions. Okay, and then later on I'll pick some questions from the comment sections as well. So we have the first question by Suresh S. Okay, the question is, how much distance to moon from Earth on 26th September? Okay, so that I will tell you in some time, because that we are going to find out using it during the activity itself. Okay, so for now I'm not answering that question. I'll pick that up later. Okay, now comes the second question by Lakshmi K. Ravi. The question is, what is the actual reason behind the rusting of the moon? Now, you must have heard about this news recently that we have found there is rusting on the moon. Around the south polar region of the moon, it is actually getting rusted. Now, it's very weird because to for the rust to happen, you need number one iron, then you need water, and then you need oxygen, right? So rust is basically oxidation of the iron. So how is that possible on the moon? Okay, so let's see if any one of you can answer that. I leave it open for the audience. Okay, let's see if you can answer that question in the comment section. Okay, I'll pick it up from here. Okay, so Neetu Bansal says that moon gets oxygen particles from Earth's atmosphere and tiny bits of water on the surface could trigger the formation of rust. That is a very brief and concise explanation of this phenomena. And you're absolutely right, Neetu Bansal, the answer is absolutely correct. Okay, so what is happening? We know that there is mineral on the moon, there is iron on the moon. So that's not a shocking thing. The shocking thing is that how can be there water and oxygen for the rust to happen? So we have already found out that we have water ice present on the moon, right? We have traces of it. Okay. Now comes oxygen. Where does it get the oxygen from? So the answer is from the Earth's atmosphere. Now, if you look at it, the moon is around 4 lakh kilometers from us. So how can it get oxygen from Earth's atmosphere? The reason is with the help of the magnetosphere of the Earth. Okay, so the magnetosphere is such a way. So magnetosphere is basically kind of a layer of magnetic field around the Earth. You know, when you take a magnet, you keep it close to an iron or a nickel object, it attracts it, or another magnet, right? But there's a particular region, a particular field in which it can do that. The same way, our Earth behaves like a magnet, and it also has that magnetic field, which we call as the magnetosphere. Alright, and that magnetosphere is of such shape that it creates kind of a tunnel going towards the moon, right? And because of that, through that, the oxygen particles which are in the upper layer of the Earth's atmosphere, as well as certain moisture, it travels through that magnetosphere and goes on the moon and results in that rusting of iron. Okay. Now remember that it is very, very small in quantity. It's not that much, but yes, it still is. Okay, so Sri Lakshmi has a question that what is the future of moon mining? And the answer is it is very, very bright. Okay, moon mining is going to be possible in the future, but it will take at least 10 years. Okay, and the purpose of that moon mining will not be to sustain the needs of people on Earth. It will actually be to facilitate the deep space travel. you know uh, NASA is working on a mission that is called as Artemis. So NASA is going to send astronauts back to the moon in 2024. All right, and the plan is to set up a base on the moon which can then be further used for deep space travel. Okay, so for that, yes, we will be going to moon mining. Okay, so we have a question by Agatyan. Now, I'm really sorry if I pronounce anyone's name wrong. Okay, I'm trying my best to get the right pronunciation. Okay, so is the moon habitable? In the current scenario, if you compare it with Earth, no, it is not. The reason being, it does not have liquid water on the surface, it does not have the protective layer of the Earth's atmosphere. Okay, and then there is no vegetation. So if I just pack my bag and go to the moon to live there, not possible, right? But yes, if we work and if we work and we are working in that direction, then we can make the moon habitable. Okay, we can live in the underground tunnels, or we can create moon bases where we have dome-like structures which will work like an atmosphere for us. Okay, in which oxygen and air and other gases will be circulating. We can mine water from the moon. Okay, and we can mine other minerals from the moon. Okay, and then rest other things which are not present on the moon will need to take from the Earth. So it in its given condition, it's not habitable, but yes, it can be made habitable. Okay, with the help of technology. And trust me guys, it is going to be possible in the near future. Okay, and I can guarantee you that within next 10 years there will be moon base present. Okay, and there will be regular you can say space flights to the moon. So it's an amazing time to be involved in astronomy. Okay, so Miss Ava Seniko says that are some parts of the moon made of plasma? If yes, what's the percentage? Okay, so Eva, it's actually true. Okay, but it's not the surface or the core of the moon which is made up of plasma. It's actually the exosphere which is made up of plasma. So moon has a very thin, almost negligible exosphere. Okay, which has plasma. You can say charged particles out there. Okay. All right. Let's move to the next question. Okay. So Suraj has this interesting question that what is the role of moon towards Earth except lighting at night and tide? It is possible to create an artificial moon. So it is actually very important because the Earth that we see today, all right, and the rotation and the revolution, the moon has played an important role in stabilizing the Earth. All right, so the way we are moving in the space, it has created a lot, and the tidal locking is the most important aspect of the moon because it helps in maintaining the ocean currents, okay, and other things. And when you talk about the lighting at the night time, I won't say that much, but in today's scenario, because we are dependent on the artificial lights. But if you talk about in the past, yes, we actually depended on it for the light in the night time. Okay, and can we create an artificial moon? It is going to be very, very difficult, and as an astronomer, I would never support such a move. And recently I have heard this news that one of the countries, I think it's China, they are trying to create mini moons. Okay, they're going to place those mini moons in the night sky, which are going to work as a source of light. Okay, but nature is something that if we play with, it is going to backfire on us. If you go along and if you play along with nature, we will prosper. Okay, we will live the best of the life that we have. But if you ever try to go against the nature, it's going to bring us down. And for past 6 7 months we all have realized it, right? The pandemic that we are facing, it is the reason that we are not going along the nature but against the nature. Okay, and the result is in front of us. For past 6 months I have not gone out of Delhi. I've not traveled anywhere, right? And I can see, and I think there would be some of you who haven't even stepped out of your house for a very long time, or who haven't gone out of your locality anywhere, right? Think about the children, okay, who are school students who used to go out in the park, play. You guys are locked inside the house, right? So it is happening because we try to go against the nature. So artificial moon is a really really bad idea. Okay, and because there are not only humans on earth, there are wild animals as well, which depend on the darkness that happens in the night time. If that doesn't happen, their life would be affected, and if they are affected, the complete food chain would be affected, right? So it is possible, technologically difficult, but not a good idea. Okay, let's see the next question that we have. So Ivan Dorji has this question: can we make a lidar by ourselves at home? So lidar is an instrument that is used to measure the distance of an object or the altitude of a surface. Okay, like how it is like. Uh, and he has this question that can we make it at home? Ivan, yes, it would definitely be possible to make it at home. Okay, but I won't be able to share the technique or how you can do it on this platform right now. But definitely, if you go online and search for it, you will be able to find an answer to this question. So Hiba has this question that why are there so many craters on the moon, right? And you have already answered the question. So she has this question that how are there too many craters on the moon, and was it by constant falling of comet or asteroids? Yes, it is actually because of the constant strikes of space rocks on the surface of the moon. Okay, now you might have this question in mind that moon and earth are really close to each other. It is just 4 lakh kilometers away. Okay, and that's a very small distance when you talk about the space and the universe. When you look at the moon, you see so many craters. When you look at the earth, you see very less craters. Why? So I'll leave the question open to the house, okay, and let's see how many of you can answer it. That why the moon has so many questions, whereas why the moon has so many craters, whereas the Earth very less amount of them. Okay, so let's see who gets it right. Till then, I'll go to the next question and then I'll come back to it. Okay. So just write down your answer in the comment section and I'll take it up from there. So Nisar has this very, you can say, cute question that I want to reach moon one day. Can you train me? So Nisar, if you want to reach moon, you have to become an astronaut. Okay, and I get this question a lot. I've been teaching students in on astronomy for more than 5 years now, and I get this question a lot that how I can become an astronaut, how I can go in space. Okay, so if you want to go to moon, first thing is that you should be physically fit to become an astronaut. Second thing, you should be good at what you are doing. Okay, so number one, choose a field of science, and you can choose any field. Now, normally people think that an astronaut has to study astronomy, okay, or has to study astrophysics. It's not necessary. Just you just take out the list of all the astronauts that has ever been, and you will find that they all are from different backgrounds. And in fact, if you talk about NASA, some of the astronauts of NASA are actually teachers and geologists. Okay, so it's not necessary that you have to pick any specific profession, but yes, it has to be science. You have to have that scientific bend of mind. Okay, you have to have that scientific temperament, and you have to be physically fit. Okay, these are the basic necessities. Let's come to the specific conditions now. That if you talk about India, we don't have our own human space missions as of now. We'll be launching our first human space flight in 2022, and as of now we don't know about the timeline that we are targeting for a lunar landing. Okay, so let's first talk about if you want to go to space as an Indian astronaut. Okay, so I would suggest you that you join Air Force or Navy as a pilot, because in the initial missions of ISRO, only Air Force and Navy pilots would be selected. Okay, the same thing happened with Russia and America and other countries, because when you are talking about space flight, you need people who already has certain experience and who are physically fit to fly a fast moving vehicle. So who do you turn to? Obviously the Air Force and Navy pilots, because they are trained to fly those jets at very high speed, right? And if you cannot do that or don't want to do that, then you will have to shift to some other countries, maybe USA or some other countries, get their citizenship, apply to their space agency to become an astronaut, pass that complete process, and then become. Now let me tell you, it is not easy, it's going to be tough, but if you persist, you will be able to do it. You have the examples of Rakesh Sharma, right, who went on to become the first Indian to go in space. You have the example of Kalpana Chawla, right, who went to space with NASA. You have the example of Sunita Williams, right. So these are the people, right, people who were one of us, right, coming from normal background, and then they went on to achieve these things. So you can also do that. So now I come back to my question again, that why don't we see that many craters on Earth whereas we see so many craters on the moon? Okay, and I can see that a lot of you have already answered this question, because the Earth has an atmosphere, whereas the moon does not have atmosphere. It has a very thin layer of exosphere. Okay, so because of which, what happens, since the Earth has atmosphere, most of the rocks that are going to fall on Earth, they'll just burn up in the atmosphere in the form of meteor. Whereas if you talk about the moon, even a small rock would hit the surface and create a crater. Okay, so that is the reason that we have lot of craters on the moon, whereas very less craters visible on Earth. But remember, we have craters on the Earth as well. Okay, but they have been eroded by they have been eroded by air, water, and some of the craters have actually been turned into cities. Yes, and in India we have a lake in Maharashtra that is called as Lunar Lake. It is actually a crater. Okay, let me get to the next question now. So Ocean Aroda has this question: can there be life on moon in future, and is there any alien life on moon right now? So Ocean, we don't have any idea right now. Okay, till now we have found no proof whatsoever of an organic life, whether it in even in bacterial form, on the surface of the moon. Okay, can there be life on moon in the future? You never know. Okay, we have not explored 100% of it. We don't know everything about it, and space is very dynamic. So things might change in future. There might be life on the moon. Okay, in future we don't know. We never know. And then there is a common question: are there any aliens? uh, we are one of the planets in the solar system. Okay, the sun is one of the stars in the Milky Way galaxy, which has around 100 to 200 billion stars. Let's say each star has at least one planet. So we have 100 to 200 billion planets. And then in the universe, we have around 100 billion galaxies. So imagine we have that many planets in the whole universe. To think that we are the only ones here would be stupidity, right? So there might be alien life, but will we ever be able to encounter it? That's hard to tell. Okay, so guys, some of you are asking me this question: are we going to see Jupiter and Saturn? That's the plan, but it's overcast over here. Okay, so we don't know when that is going to happen. Okay, so what I'm going to do, I am going to take it completely virtual rather than showing you through the telescope. I'll actually be showing you through a simulation. So remember, I told you that we can use simulation technique to observe the night sky virtually. So I'll be using that to show you. Okay, so while I set that up, I have another program for you guys. So just like we have astronomers and astronomy club for hobbyists, similarly I have another program that we have launched for the people who want to make a career out of astronomy. Okay, so that is what we call as the Voyager. So Voyager is a foundation course in astronomy where we will be covering all the major basic topics of astronomy. So once you do that, you'll have a lot of knowledge of astronomy and you will be a certified amateur astronomer. Okay, so while I set that up, just have a look at it. Okay, so it took me some time, but sorry for that. Now we are over here. So you have seen the video of Voyager. So it's basically a foundation course in astronomy where you will get to learn about the major topics related to astronomy. Okay. Now, how you can enroll for that, or how you can join us in either iAstronomer or Voyager. So there in the at the bottom of this video, you are getting this scroll. Okay, so there we have the website, right? learn.space-india.com, and you also have a WhatsApp number. So if you have any query related to that, or if you want to enroll, just WhatsApp us or just go to the website and we'll get back to you. Okay, so the software that we are going to use is called as Stellarium. Alright, it's basically a sky simulation software through which you can find out that which all objects are going to be in your night sky on any day and at any time of the year. And not just this, you can actually go to some other planet or the moon of the solar system. So sitting at your home, just working on your laptop or phone, you can actually see how the sky would look like from any location in the complete solar system. Okay, so over here we are going to take help of that, and we are going to see the moon and Jupiter and Saturn in the sky. So let's get to Stellarium now. Okay, so this is how the Stellarium looks like. Okay, the just make it a little bigger for you. Okay, so over here at the bottom, you can see that we have the location as Earth Delhi, because I have my location at Delhi. Then you have the time, date, time zone, right? You have the ground over here. You can see the horizon, right? And in our sky, I think you can spot the moon, Saturn and Jupiter. So this is how the sky would be if I just go outside. Okay, if the sky clears up, if I face the south direction, I'll notice that the moon is exactly in the south. Okay, then right next to it on the right hand side we have Saturn, and on next to it we have Jupiter. Okay, so if the sky gets clear up tonight, go outside, have a look at it. You will find the moon right next to it. We have the Saturn, and right next to that, the brightest one is the Jupiter. So first, let's just go to moon. You select it, and then you zoom into it. Now, as soon as you click on it, on the left hand side, you will get all the information of the moon. Some of you, one of you had asked me this question, that how far it is from us tonight. So if you just go over here and look for the distance from us, you will find out the distance. Let me just find it over here. So you can see the distance from the sun over here and the distance from us is 3,86,759 kilometers. So the current distance of the moon, as we are talking, it's 3,86,760 kilometers. Okay, and you can see it is continuously changing because the moon is continuously moving. You can find all other details over here, right? Okay, now let's zoom into it. So if you remember the visual correctly, this is how the moon was looking like from the telescope. I think all of you would agree, right? So this is how the moon looks like. So this gives you the actual phase, the orientation that is in there in the night sky. All right. So we are quickly going to do some activities where we'll try to identify some features of the moon with the help of the stellarium. All right. So I want all of you to be ready with your document. I had already asked you to, keep it with you. Okay. So we are going to look for certain features. Okay, some of the most common features that we have. So first is the Copernicus crater. Okay, you all have the document with you. You have the visual right here on the screen with you. Okay, let's see in this visual, can you identify the Copernicus crater? I'll give you a minute's time to identify Copernicus over here. Okay, till that time I'll just answer the next question. So there's a question by Mani Megalai Sundarsan. Okay, I'm sorry for the wrong pronunciation if I'm doing that. So she has this question: is it possible for a housewife like me to visit ISRO? And I would say that astronomy is something that is equal for all. Okay, and the same is with our institution as well, ISRO. So it is open for all. Now you are asking me that as a housewife, as a homemaker, can you do that? Definitely you can do that. Okay, and it is actually open for all, but obviously you will need to take permissions, and on certain occasions they open up their facilities for the general public to visit. It wasn't the case earlier. Okay, earlier it was very, like, it wasn't open to the public, but now it is. So you just have to apply for the permission that if you want to visit their facility, or look for the launch dates of the space the missions by ISRO, because during that time they have, they open up their launch gallery for general public. You apply for the pass, you get the pass, you go over there, then you can visit the ISRO facility. So yes, it is open for all. Let me get back to you and let's see. Okay, so I can see a lot of you have found the Copernicus crater. Okay. So to tell you, I first need to show you the direction. Okay, so this side, uh, just a little right from the top hand, okay, that is your north. Okay, so then that is how you can identify the other four directions. So some of you have said north left, which is actually correct. Now let me zoom into the Copernicus crater. So the one that you have in the center right over here, just on the terminator line, the line that differentiates between the dark and the light side on the moon, okay, the dark and the bright side on the moon, that is the Copernicus crater right over here. Okay, now let us get back to the next feature, and this one is the Apennine Mountains. Let's see who can identify Apennine Mountains. So I'm not going on very small features for now because the moon is not there in the sky. Okay, it is covered by the moon. Sorry, it is covered by the clouds. It's not visible. So I'm just doing with the some of the brightest features that we have, okay, which are easily identifiable. And you know, this program that I'm showing you, Stellarium, is a free program, okay, which you can install in your laptop, okay, and then you can do this activity and many other activities with the help of this software. So GR10 has this question that it has been so long since anyone visited the moon, and it actually has been almost 50 years. The last mission was in 72. So what was the problem? Because we have better technology now. So actually, when you talk about the Apollo missions, it started actually out of a race between USSR and USA. Okay, so at that time there was, you know, a race to be the leader of the world, to create that dominance. Okay, so that was the purpose, that who gets to go to the space first, who gets to step on the moon for the very first time. It started out of that. And at that time, once we were done with Apollo missions, there were problem in the funding, okay, and then there were problem in with the political will as well. Okay, so we diverted our mind from the moon to other missions. Okay, at that time, whatever we wanted to do, we actually had achieved. Okay, and scientists kind of did not have enough objectives to go back to the moon, right? That is why it was stopped. But now things are changing, and we are going back to the moon. So as I told you about the Artemis mission by NASA, so by 2024 humans will be back on the moon, and this time one of them will be a female astronaut. So till now, on moon only male astronauts have landed. Okay, but going forward in Artemis mission, we'll be having a female astronaut as well. Okay, so back to Apennine Mountain. Have you identified it in the image that I have on the screen? So again, the Apennine Mountains are actually right next to the Copernicus crater. Let me zoom into it, and these are amazing feature. So when you see this, so you already identified the Copernicus crater. Right next to it, this range of hills that you see is the Apennine Mountains. Now, unfortunately, it is not very focused. Okay, the image that we have in the stellarium, but till the time clouds clear up and we have the visual, this is what we'll need to do. Okay, now let's identify some mayors. So we saw the bright features on the moon, right? Let's see some mayors. So first thing, let us identify the mayor in which Neil Armstrong and Buzz Aldrin landed. Okay, so that is known as Mayor Tranquillitatis, and let's see how many of you can identify it in the visual that you have on your image, on your screen. Let's see how many of you can do that. So one of you have this question that what happened to Chandrayaan 2? Well, nothing happened to Chandrayaan 2. Okay, it is still orbiting the moon. It is studying the moon. It is capturing photograph, collecting data, and sending that data back to us. So the lander unfortunately didn't work. Okay, we don't know whether it crashed or it survived the crash or not, but the orbiter is perfectly fine and it is still orbiting the moon and collecting the data. So let us see whether you have identified Sea of Tranquilitatis, the Sea of Tranquility. Okay, Mare Tranquillitatis, and I can see that some of you have done it. So it is actually this mare that we have. So the mare that you have in the center of this visual, this is the Sea of Tranquility, or what we call as the Mare Tranquillitatis. This is where Neil Armstrong and Buzz Aldrin had landed. Now the sky is getting clear at my end, and I am going to give you the visual of Saturn and Jupiter. Okay, so for now I'm trying to align to the Jupiter. Till then, let's see it in the stellarium, that how the Jupiter looks like. So this is Jupiter. Okay, let's get it right over here and let's zoom into it. So you can see this is how the Jupiter looks like. You can see the band structure on the Jupiter, the dark bands that you have, right? So, and right now, tonight, we have a moon that is Io, one of the four Galilean moons of Jupiter, Io, right in front of it. Okay, so we'll see it as black spot in front of the Jupiter. Let's see if we can get that on the visual of our telescope, and then I'll show you. And when you see it, try to make out this band structure on the visual that we have. Okay, other than Io, we have Ganymede, Europa, and Callisto as well. So you can see, you will see the Jupiter and the three moons next to it, right? You cannot see Io because it is right in front of it. So out of the 79 moons that we have of Jupiter, 4 we can see from Earth, which are known as the Galilean moons. The reason being, you have because they are big enough and because Galileo was the one to find it. So this is how the Jupiter is looking like right now. Tell me guys, how's the visuals? Okay, have a look at it. Tell me how does it look like. Okay, my mic got turned off, but it is on now. Okay, you might be hearing me now. Just let me know whether it is working or not, or whether the audio is there or not. Okay, and then tell me, how do you find the Jupiter to be? This is how it looks like when I'm not zooming into it, and now I'm going to zoom into Jupiter. You will be able to see the bands of Jupiter clearly. Now I'm going to go zoom into Jupiter. So this is the 5 times magnification of Jupiter, and tell me, can you clearly see the band structure on the Jupiter? Now here you are looking at a planet, okay, which is really far away from us, almost 600 million kilometers from us. And I think you can clearly see the bands of Jupiter. So are you ready to see it next level? This is right here. So the image will not be very sharp because of the turbulence that we have and obviously the weather problem that we have, okay, but you can clearly see the bands of Jupiter right over here. This is a very interesting question related to Jupiter. Asta asked this question that how do we see Jupiter from Earth even though it is beyond the asteroid belt? So you know, when you talk about the solar system, you have the sun in the center, then the 4 rocky planets: Mercury, Venus, Earth, Mars. Then you have the asteroid belt. Then you have the Jupiter, Saturn, Uranus, and Neptune. Okay, so normally people think this that the asteroids are very close to each other. So if a rocket is going across it, it will be damaged. So actually, the asteroids are not very close to each other. They are actually very far from each other. Okay, and that is the reason that you can actually see through them. Okay, see through the asteroid belt, and that is the reason that if a rocket is going across it, okay, it will not be damaged. There is enough space out there. So this question by Akanksha Sharma, that why have you chosen northern hemisphere of the moon to be shown to us in the webinar? Let me correct you over here. The map that I have given you is not of the northern hemisphere of the moon, but actually it is with respect to the orientation of the moon as seen from the northern hemisphere of the Earth. Okay. So if you look at the southern hemisphere, you can easily find it out on the internet. So basically what happens, for people who are in southern hemisphere, the moon would be upside down of what we are looking. So this map is for people who are living in the northern hemisphere of Earth. And since most of my audience is in the northern hemisphere of Earth, that is why I have given you this map. So I hope that you have enjoyed the Jupiter's view now, right? Let us. Okay, one of you says that red spot. So red spot is not actually facing us. Okay, as of now it is not facing us, it is not towards Earth, so I cannot show you, right? Otherwise I would have definitely shown you. Now let us see the Jupiter with its moon. So I'm going to overexpose this image so that the Jupiter will be exposed out, but you will see three dots in line on right and left hand side of the Jupiter. Okay, very good. Now I hope that you can see, if you see diagonally left hand side you see one dot, and diagonally right hand side you see two dots. Okay, so these are the three Galilean moons of Jupiter. Just have a look at the visual in this stellarium. So you can see we have the Jupiter, we have the Europa and Ganymede and Callisto, right? The visual that you are getting from the telescope is actually the mirror image of that. Okay. Now, I'm gonna take you to the next member that we have in the night sky tonight. Okay, that is going to be Saturn. So till the time it gets worked out and we get to see Saturn, let's quickly see how it looks like in the stellarium. Okay, so let us zoom out of Jupiter, and we have the Saturn over here. We select it and we zoom into it. So Saturn is, one of the most beautiful planets we have, and one of the most common targets of astrophotographers who are into planetary photography. Okay, the reason it happens because it is known as the Lord of the Rings, and because of its beautiful ring structure that it has, right? And when Galileo observed it for the first time, he called it as planet with ears. The reason being, it has those rings, but when you look at it from a small telescope, you will see a small dot with flaps around it. Okay, so that is why he called it planet with ears. Okay, this is how it looks like in the simulation. In some time, I am going to show you how it looks like through a telescope. Okay, now Saturn is the planet that if you make a big enough pool and if you keep it in that pool, it will actually float around. Okay, its density is such. All right, and it has the largest number of moons in the of any planet in the solar system. Now, so we are moving towards the end of our observation. At the end I will be taking you back to the moon, showing you the zoomed in version of the lunar features. Okay, till then if you have any question, type it in the comment section of the video and I'll take it up from there. Let me just check whether the Saturn is back in the field of view or not, and let me see if I can take any other question from the registration form that you had submitted. So Shubhi Sharma has this question: what is the difference between microgravity and lunar gravity? So Shubhi, microgravity is the term that we use for gravity condition while we are in space. Okay, as soon as we leave the earth of the atmosphere of the earth, we enter into the space, we feel this weightlessness condition, and we think that gravity is not there, but actually it is there, but we are in a constant condition of free fall, because of which we feel like that gravity is not there. Okay, so that in that scenario what we have is what we call as microgravity. When you talk about lunar gravity, it is the gravitational force on the moon. Okay, how is the gravitational force on the moon? And that is 1/6 of that on the earth. So they are quite different. Okay, all right, let me take next question. So Molly Dubey has this question that I want to have insight and understanding about the moon temperatures. Okay, so before going to that question, let me bring up the visual from my camera so that you can see the Lord of the Rings on your screen. So you have Saturn right over here. Let me take it back to 1x. So this is how it would look like if you are at normal zoom through a 10-inch telescope. Okay. Now, if I zoom into it 5 times, This is how it looks like, and I think you can easily make out the ring structure around the Saturn. Okay, I'll come back to the question that Molly Dubey asked, that how's the temperature condition on the moon. So the moon has very slow rotation period. It's just 27.3 days. Okay, so and it does not have any atmosphere, so there's no way to regulate the temperature on the moon. It is solely because of the sun, right? So the side which faces the sun will be very hot. Okay, the temperature can go more than 100 degrees, and the side which is in the darkness away from the sun, it will be very very cold. Okay, so this is how, so on moon we have very high variations in the temperature in the daytime and in the night. Let me go back to the Saturn and let me make it more magnified for you guys so that you can enjoy the visual in greater detail. So this is how the Saturn looks like right now. So if I talk about the focal length that is there right now, it is at 25,000. What do you say? 2,500 focal length. Okay, and further 10 times magnification. So you're actually looking at 25,000 of focal length, and this is how it looks like. So Piyush Vadera has this question that like Jupiter, it is all gas. Saturn is also same, or it has solid matter like Earth. No, again Saturn is also a gas giant. Okay, like Jupiter, but it is believed that all the gas giants have a solid core in the center. Okay, but out of that it is all gas. And then in the rings around the Saturn, you have a lot of rocky and icy objects. So one of you has asked me that, sir, which telescope is best for beginners? So the answer to this question is it depends completely on your budget. Okay, the telescope, the best telescope that you can get in your budget is the best beginner telescope you have. To start with, you can have a 50 telescope, then you can go to 76 or 200 and then further. Okay, but again it completely depends on your budget. So just go for the best telescope in your budget. That will be the best beginner telescope you have. So are you ready to see the moon once again? If yes, we are going to go to the moon now. The sky is super clear, okay? And now I'm going to point my telescope to the moon. So let's go to our natural satellite, the object that we are celebrating tonight, okay? It's International Observe the Moon Night tonight. So let us go back to the moon and observe it. Till that time it comes back on my screen, let me take you back to the stellarium. So further, if you just zoom out, you can get a lot of other information about your sky, that which all constellation and which all stars are out there in the sky. Okay, so if I just press C in here, you can see the lines that you see, they're actually the constellations in our night sky. Okay, if you were at a dark location, and if you are at a dark location, you go outside, you can make these shapes by joining the brightest stars in the sky. Okay, let me show you the name of these constellations. So we have moon back in our field of view, and you can enjoy this visual for now. So it's 9:20 p.m. now. We have actually gone past beyond our scheduled time. Okay, so this is going to be the last section of our webinar. All right, I hope all of you enjoyed it. Okay, and if you did, just Share your feedback in the comment section that how was the webinar. And moving forward, if you need webinar on a particular topic, do leave it in the comment section and we'll definitely pick it up. Don't leave the webinar yet, because we are going to magnify and show you different features of the moon. Okay, so just wait for some time, share your feedback with us. All right, and remember, if you are interested in learning more of astronomy, okay, and become an amateur astronomer, just go on to our website learn.space-india.com and and enroll for the various courses that I showed you. Okay, so I can see that clouds are coming up, so let me quickly go to the moon and show you Copernicus crater in higher magnification. So you can see the Copernicus crater right on your screen. Let me just increase the brightness a little bit. Okay, so you can see the Copernicus crater, and remember I told you that every crater has a mountain in its center, okay, and you can see that clearly right over there. And just imagine the depth of this crater, you just see the shadow of the rim. So that shows you the direction from where the sunlight is coming up. So clouds have come in front of it. Okay, so that is why the brightness has gone down a little bit. Let me just pump it up for you. So this is Copernicus crater. Let me zoom out of it. Okay, don't worry about the brightness. I increased it so that you can see beyond the clouds as well. Okay, Apennine Mountains. Remember, I asked you to identify this feature. Let us zoom into that. So this is kind of a mountain range on the moon. And you know, it has valleys, it has mountains, it has craters, it has meres. So this is kind of a mountain range on the surface of the moon. Okay, enjoy it while you still can. Okay, so I hope all of you enjoyed the view that we had. So this is actually last visual that we got. Okay, the moon would not be back in our visual. If it happens, I'll show it to you. So now I would like to wrap up the webinar. First of all, a big thanks to all the audience, all of you who took out time and who attended this webinar to celebrate the International Observe the Moon Night. You don't know that you are actually part of a huge worldwide celebration. Millions of people all over the world are celebrating International Observe the Moon Night right now as we are talking. Okay, and you are part of that. So first of all, a big thanks to all of you. I hope that all of you enjoyed the webinar. You got to learn a lot of new things, okay, and you got to ask questions, and I hope that I was able to give answer to some of those questions. Now I know that I have not covered all those questions, and I'm really sorry for that, but you know that practically that is not possible. Okay, I'd like to thank Mr. Sachin Bhamba, who is the founder and the CMD of Space Group, okay, for giving us this idea of this webinar. So it was actually his brainchild, and we are the team that made it possible. Okay, thank you to Pooja, who handles the outreach department of space, who took care of everything related to the announcements, you know, informing you guys, interacting with you guys. So she is the one who managed that. And Yogesh, who is the assistant education in charge at Space India, so he made it possible for me to bring these visuals to you. So, you know, to make such a webinar possible, it needs a team. All right. And this was the result of that teamwork. And I should also take name of Vivek, who helped us in managing our social media. All right. So thank you, Vivek, for doing that for us. And thank you to all my team and the people who joined us tonight to see the moon, Jupiter, and Saturn. And I hope that I made your time worthwhile while you attended this webinar. So with this, we all from Space India bid you a goodbye. It was nice interacting with you. I, Tarun Sharma, wish you all clear skies and do start astronomy. If you are doing it, amazing. If you have not yet started, this is the right time to start astronomy. Until next time, wish you all a very, very healthy life. Stay safe and enjoy astronomy. Thank you, everyone. Bye bye.